Hello everybody and welcome to part 15 of my FTC programming tutorial videos. This video is going to be a continuation of the previous one, talking about autonomous programming. In this video we're going to talk about the ElapsedTime variable type and running our autonomous mode based off of timings rather than running it based off of sleep like we did in the previous video. So what I have here is just the autonomous mode that I had set up in the previous video, just renamed and put in a new file. And just a quick reminder over what this file actually did is it set the power to all of our drive motors to be 0.5, and then it allowed them to run for 500 milliseconds. After those 500 milliseconds, we call request op mode stop. Now, you don't really need to use request op mode stop. I just used it to be kind of explicit in this case, but once your program reaches the end of run op mode, it's going to stop the op mode. So, reasons for why this is not best practice is we're using sleep here. Now, sleep can be fine, and in fact, I would probably recommend that you start your autonomous programming journey using sleep, but when we start running more things than just the drivetrain, sleep becomes a problem because it prevents our program from doing other things while we're driving around. So this sleep is going to pause absolutely everything in our teleop program, including some things that are running in the background, because everything that controls hardware in FTC is run off of a single processor thread, meaning only one thread is allowed to control hardware at any given time. The sleep function pausing that thread for 500 milliseconds in this case, or however long, is going to prevent other things in our robot from being controlled. So if we have a motor that's running in encoder mode and it's trying to hold a position or hold something up for us, something we'll talk about in a future video, that is going to stop, and that is bad. So what we want to do is we want to allow our program to continue to run without using sleep, but we also want to keep track of the timings so we know when to stop our motors. So that's where ElapsedTime is going to come in. So ElapsedTime is a new type that I have yet to talk about. And all it is it's basically just a timer. So we talked about deadline. Deadline is a subclass of ElapsedTime. So deadline has a specific interval that you're working with. ElapsedTime is just going to keep track of total runtime. So after creating all of our drive motors, I'm going to create a new ElapsedTime, and I'm going to call it runtime. And so now in this case, after we've set the power to all of our motors, we can call runtime.reset. Now I'm calling .reset here because once we create runtime here, it's going to start to count for the duration that this wait for start function is paused for, and we don't want that. So once we call runtime.reset, we can create a while loop of while op mode is active. Now we want this here because if we go to stop our autonomous program while we're in this loop, we want to make sure that it actually exits all the way. So we're going to do that, and then we're going to do runtime.seconds, and then we're going to make sure that runtime.seconds is less than whatever interval you want to have your drive motors run for. So in my case, I'm just going to choose 1 because it's nice and easy. This should actually be 1.0 because this is going to be comparing against, I believe, a double, but I could be wrong about that. Now, once we have this set up, what we want to do something in here. You can either print something to telemetry, or if you want to do nothing, you can just call idle. Idle is a function that you used to have to call in every while op mode is active loop, but it got, what's the word? It's not depreciated, but it got included automatically. So you don't technically need to be explicit about calling idle anymore. I'm just going to do this as sort of a placeholder for code. There's absolutely nothing wrong with using idle in this way. So once we do that, our motors are going to run at 0.5 power for a full second, and then they are going to stop because we're going to stop our op mode. What if I wanted to do something else with them? What if I wanted to, let's say, after I drive forward for 1 full second, let's say I want to turn to the left for 1 full second. So let's kind of do that. So if we think about it, if we want to turn to the left, We're going to need our left side motors to run backwards, and we're going to need our right side motors to run forwards. So I'll just set these to 0.5. And then we can set our right side motors to 0.5. Once we have that, we have to call runtime.reset again so we can reset our timer. You don't have to reset your timer. If you wanted to, you could just assume that this is continuing off of the previous, and let's say I wanted to run it for another full second. I would say that our runtime.seconds is less than 2 instead of less than 1, but I'm going to keep it a little simpler just to be sure that we're running for the exact amount of time we want. We want op mode is active, and runtime.seconds is less than 1.0. So now we're going to be turning to the left for 1 full second as well. Now you can continue this, you can do different things. Let's say I wanted to add a pause in between these two actions, so I could do something like this. If I wanted to pause, I could set all of the motor powers to 0, and then I could do something like this. So now our op mode is going to pause halfway through our actions for a full second. Maybe I don't want it to be a full second. Maybe I want it to be, let's just do half a second. So now what we're going to see here is our autonomous mode is going to drive forward for 1 full second. It's going to pause for half a second, and then it's going to start to turn left for another full second. You can kind of continue this, add some different actions. Not all of these things have to be done with the drive motor. So for example, during this pause, if we wanted to do something with an arm motor, you could do that here. You could pause all of the set power, or you could set your drive power of all of your motors to 0, and then you could continue with setting the position of a motor inside and then wait for it to get to its desired position. This is something you're going to have to kind of play around with and get used to. Now, these timings, as I mentioned in the previous video, are going to not be super precise, so setting the power of your motor like this without feedback from an encoder, you're not going to get the exact same result every time. That's just something you have to be aware of, but you can get pretty good with it if your timings are pretty tight. All right, I hope this video was helpful for you. If you have any questions about anything I showed you in this video or anything else, please let me know. If not, I will see you in the next one.